Quantum computing. You've probably heard of it. Is it really the key to solving humanity's biggest problems, or is it just the most expensive science fiction story ever told? Well, today we're going to try and separate that world-changing potential from the hard scientific reality.
The buzz, the excitement around quantum computing, it's all built on some truly massive promises. I mean, we are talking about a technology that a lot of smart people believe will fundamentally reshape entire industries and maybe even our world.
Just think about it for a second. Imagine designing a new life-saving drug. A normal computer has to test every single possible combination one by one. That could take thousands of years. The promise of quantum is that it could explore all of those possibilities at once, and that is where all this excitement comes from.
Right, so that's the billion-dollar question, isn't it? And the answer isn't just about building a faster chip. It's about completely rewriting the fundamental rules of how we compute anything at all.
It all starts with the most basic unit of information. You know, your laptop, your phone, they all run on classical bits. But quantum computers, they use something else entirely. And this is where things get really interesting. Okay, so here's the crucial difference. A classical bit is kind of like a light switch. It's either on or it's off, 1 or 0. Simple. A quantum bit, what we call a qubit, can be both on and off at the exact same time. Now, this isn't just a small upgrade. It's a completely different way of thinking about and holding on to information. This wild property is called superposition. Let me give you an analogy. Imagine a classical computer trying to find an answer in a library. It has to pull out every single book, one by one, to check. A quantum computer, because of superposition, can essentially check all the books in the library at the very same time. That ability to explore a huge number of possibilities all at once is where its incredible power really comes from.
And you know what? It gets even weirder. The second key idea is something called entanglement. Imagine you can link two of these qubits so that their fates are totally intertwined. Whatever happens to one instantly tells you something about the other one, even if they're miles apart. This isn't just a weird science trick. It's a computational superpower that lets these machines perform incredibly complex calculations that would otherwise be impossible.
Okay, enough theory. How does all this mind-bending physics actually translate into real-world value? Well, it turns out some of the world's biggest companies are already placing their bets. Yeah, this isn't just happening in university labs anymore. You've got global banks like JP Morgan and HSBC exploring it for financial modeling. Automotive giants like Mercedes and Ford are using it to research better battery designs. And in the pharmaceutical world, companies like Pfizer and GSK are investing in it for drug discovery. They're all trying to get quantum ready. And they're tackling these very specific, gnarly problems that make even our best supercomputers choke. For a company like JP Morgan, it's about trying to find the single best investment strategy out of trillions and trillions of possibilities. For Mercedes, it's simulating the incredibly complex quantum behavior of atoms inside a battery. These are exactly the kinds of massive, parallel problems that quantum is perfectly built to solve. And the potential economic impact? It's staggering. We're looking at projections that by 2035, the value at stake could be in the hundreds of billions of dollars for industries like finance and pharma alone. So yeah, the race is definitely on. But for all this amazing potential, the path forward is incredibly difficult. So it's time for a little reality check on the massive hurdles and some of the big misconceptions that are standing in the way. Here's the thing. Building a working quantum computer is just ridiculously hard. The qubits themselves are extremely fragile. The tiniest vibration or change in temperature can just poof, destroy the whole calculation. We call that decoherence. These machines need massive, stable setups running at temperatures colder than deep space. On top of all that, fixing errors is a huge puzzle. And frankly, there's a major shortage of people who even have the skills to build and program these things. All this complexity has also led to some pretty serious myths, so let's bust the most common one right now. You hear this all the time. The idea that because these entangled particles are linked, you can use them to send information instantly, breaking the speed of light. Yeah, that's just not true. While the correlation between the particles is instant, you can't actually control the outcome on your end. It's random. So there's no way to encode and send a useful message. It's a truly fascinating piece of physics, but it is not a galactic telephone. And let's just clear up a few more real quick. A quantum computer will not replace your phone. It's a specialized tool, like a Formula One race car, not your daily driver. It's also not just faster. It's a completely different way of computing. And sorry to disappoint any sci-fi fans out there, but quantum teleportation is about moving information, not people. No, beam me up, Scotty. So with the hype checked and the reality kind of established, where does that leave us? What's the big takeaway here? How should we really think about the quantum future? I think the most crucial point to get is this. We are not going to wake up one morning and find that quantum computers have replaced everything. This is a gradual evolution. Think of it more like a rising tide that's going to slowly lift certain industries and capabilities over a long period of time. And you know, what's really interesting is that the biggest challenge might not even be the hardware. As the Forbes Technology Council points out, it's going to be about having the people, the scientists, the engineers, the business leaders who actually understand how to use this brand new way of computing to solve real-world problems. So the path to getting quantum ready isn't about running out and buying a machine tomorrow. It's really a strategic journey. You start small by identifying the right problems. You experiment using cloud platforms that are actually already out there. You build up that internal knowledge you're going to need. And critically, you have to plan ahead for the disruptions, especially when it comes to things like cybersecurity. So yeah, the quantum era is coming. It's not a sudden storm. It's not a flip of a switch. It's that slow, rising tide that's going to reshape our world. The hype is absolutely real, but so are the challenges. The only question left is, will you be ready when it arrives?